that's just for a little information. Okay, so right now we have this trapezoid. Okay, so now what I want to do is I want to just look at this trapezoid. Okay, so this trapezoid, all right, if you look at this trapezoid and you look at this trapezoid, all right, what did I actually do here? So notice the length of this side for the trapezoid, all right? So notice this length is B, that's A, that's B, and that's A. Well, what if I just wanted to make one trapezoid with like only one of the sides, for example, these two sides being represented just by one side, like we have here. So for example, if I told you A was 5 and I told you B was 10, and I wanted to know the length of this entire thing, well, what would you do? You would say, well, if A is 5 and B is 10, then this whole thing is 15. All right, you would do A plus B, and that's exactly what we're doing here. Okay, we're just going to call this entire side here A plus B, because it is. That's exactly what it is. It is A plus B. So here we have A plus B. All right, and we have the top stays the same, which is A, and then we have the bottom, which is B. So far we've gone from this one up here to stacking them up so that they look like this, okay? Then we went from like a kind of general trapezoid to like an exact trapezoid. And then what we did was we changed this length. Instead of writing A and B and using all these triangles and stuff and using these triangles, we said, okay, let's forget about the triangles for a second and let's just look at one solid figure with the same dimensions. Okay, so the A, this is still B, right? That's still A. And instead of A and B separately, we're just going to do A plus B because that's what it is. All right, this is A plus B. So now here's what we're going to do. Okay, so now we know that this trapezoid is equal to 2 of these red ones, right? Looks like this and like this. Okay, but geometrically these are the same. So it's equal to 2 of the red ones like that. Okay, here's the 2 red ones. Okay, this trapezoid, right? It's equal to 2 of the red ones plus this gray one that has length C. So maybe you guys noticed that this length, this triangle that we made here, we actually made a triangle with that right angle. And it has length C and C. Okay, C and C. All right, so this is actually, so we actually have 3 triangles here. All right, so what we're doing right now is we're breaking up this triangle. First we're taking it as one triangle, and then we're representing it as 3 separate triangles. All right, so now here comes the it gets a little bit more confusing. All right, so hopefully you guys are okay with this so far. So far we've just broken up this trapezoid into the 3 that it was originally, right? 1, 2, 3. And here we have them right here. 1, 2, 3. So now what I want to do is to show the a squared plus b squared equals c squared. All right, so remember this was our goal, right? How are we going to show this using the trapezoid method? All right, that's what we wanted to show, a squared plus b squared equals c squared. Well, this is how you're going to show it. Okay, and it gets a little bit confusing, so try to pay very, very close attention. Okay, so the first thing I'm going to do is, I'm not sure if you guys can see this. Okay, so let's move this up a little bit. Actually, you know, I'm going to put these 2 on this next page. Okay, so let's do this. Let's start with a clean slate, just like this. Okay, so we know from this picture, all right, from this picture over here, okay, this picture's not involved. Maybe I'll do this because it helps. So we know from this picture, right, that this trapezoid here is kind of like it's equal to these 2 plus this one, right? It's equal to 2 of the red ones plus a gray one. 2 of the red ones plus a gray one. All right, but now here's what we have to do. Now we have to take into consideration areas. Okay, and we're going to use the areas of triangles, and we're going to use the areas of the trapezoid. And then we're going to get to a point in this solution where we have something very, very nice with these original numbers, A, B, and C. Okay, so real quick, let's go back and let's recall this real quick. So remember that the area of a trapezoid is A. It's the sum of these. It's the sum of the parallel sides times the distance between the parallel sides times 1/2. All right. So let's go and apply that here. Okay. So it's the sum of the parallel sides. So in this case, if we add the sides that are parallel, we get A plus B times the distance between the parallel sides, but the distance between the parallel sides is A plus B. So the distance between these parallel sides is A plus B again. A plus B. So the first A plus B is because you have to add the two parallel sides. Okay, you add the two parallel sides, that's this one. And then this one right here, this one is the height. Right? And the height is the distance between the parallel sides, which was A plus B. A plus B. Times 1/2. Right? We need that 1/2. Okay? And that's going to be equal to, now look what we have here. Let's deal with the areas on this side. The areas on this one will be easy. Okay? We have two of these red triangles. Two. So we're going to have two of the same areas. So 2 times, what's the area of a triangle? 1/2 the base times the height. So 1/2 of the base, 1/2 times the base in this case is B, but I'm going to write it as AB, so it looks it's going to look nicer. All right, times A times B, and I'm using parentheses notation for multiplication. All right, so I have two of these red ones. So here's one red one, but I have two of them. That's where this 2 is coming from. So this by itself is just one area for one of the red ones, right? 1/2 A times B. All right, but we have two of them, so we multiply by 2. So, okay, not that bad. Plus, what's going to be the area for this triangle here? Well, this triangle, remember, it got created from this triangle. When we extended that line right here, it got created from this triangle. C, and it has length C, which was like from this triangle's hypotenuse, and it has this triangle's length hypotenuse, which is also C. So now we can just call this one 1/2. Instead of C times C, remember thing times thing, back from squares, thing times thing is thing squared. So maybe I'll write it like this first to start off. Okay, so 1/2 the base times the height. But hopefully some of you guys can already see that. You get 1/2 times C, but C times C is what? C squared. Okay, so let's keep going with this. Okay, so right now we have 1/2 times A plus B times A plus B equals to 2 times 1/2 A times B plus 1/2. I'm going to rewrite C times C, right? The area of this triangle, 1/2 C times C. I'm just going to say 1/2 C squared. All right. So now here's what I'm going to, now it comes down to some algebra. All right. And I know algebra isn't something, we're not extremely comfortable with it. But the easiest way that I've found to explain this part and how we're going to move forward from this part is to multiply every single term. So that means multiply this piece here, this whole piece here, by 2. Multiply this whole piece here by 2. And we're going to multiply this whole thing here by 2. So in other words, we're going to multiply both sides. What you do to one side, you do to the other side by 2. So I'm going to multiply this side by 2 and this side and this side by 2. And that's the same thing as multiplying every single thing by 2. All right. So let's multiply this by 2 first. So we're going to have 2 times 1/2 a plus b equals to 2 times 2 times 1/2 a times b plus 2 times 1/2 c squared. Hopefully that's not too confusing, right? Here's the 2's for everything. Here's the 2 for this one. I just multiplied every single thing by 2. Now you guys are going to see right now why I wanted to do that, okay? Because it takes away, because it gets rid of our fractions, all right? And fractions just they make things more complicated, so it's always nice to get rid of them. And in this case, this is how we're going to get rid of them. Watch, because 2 times 1/2 is what? What's 2 as a fraction is 2 over 1 times 1/2. To multiply fractions, you go straight across. 2 times 1 is 2. 1 times 2 is 2. And you get 2 divided by 2 is 1. So that means that this part right here equals 1. Okay, that's nice. 1's nice because 1 times anything is that anything. So 2 times 1/2 here, we get 1 times this, which just becomes that. A plus b times a plus b equals to 2 times 2 is 4, right? 2 times 2 is 4. 4 times 1/2 is, well, 4 as a fraction is 4 over 1 times 1/2. 4 times 1 is 4. 1 times 2 is 2. 4 divided by 2 is 2. Okay, so that means that this whole thing just turns into 2 times a times b. So you get 2ab plus 2 times 1/2, again, we have up here. 2 times 1/2 is 1. So this part just becomes 1. So we're just left with 1 times c squared. But 1 times anything is anything, so you just get c squared. All right? So now what we can do is this. So just bear with me. I know this is it's getting a little confusing. All right. Now we're going to do this thing called the distributive property. Okay, so the distributive property says what you do here is you multiply this one with each one of these two, and you multiply this one with each one of these two. So the distributive property says to do this: multiply this first guy with this second person, and then multiply this person with this next person, and we're adding. Okay, I think this shouldn't be the first time you're seeing distributive property. So now what we're going to do is we're going to do a times a, which is a squared, a times b, so plus a times b is ab, plus, now it's this, now, okay, so now a's turn is over. We already multiplied a with this one and with this one, right? A times a squared, a times b, ab. He's done. Okay, now it's this one's turn, b's turn. B times a is ba, but you can also write ba as ab because multiplication is commutative. So you switch it, ab. We're going to see why right now. Plus, this last one, b times b. What's b times b? B times b is b squared equals to 2ab plus c squared. All right, so hopefully you guys are starting to see something that we're going to be able to do soon. What's one of these ABs? Imagine one of these, imagine this right here, this pen is an AB. What's one AB plus another AB? It's 2 ABs. All right, so now we have a squared plus 2ab plus b squared equals 2ab plus c squared. All right, I'm just going to rewrite that up here so it's a little easier to see. A squared plus 2ab plus b squared equals 2ab plus c squared. Now let's do a little bit more algebra. So here's what we're going to do now. Now over here, what I'm going to do to both sides, I'm going to subtract off, I'm going to take away 2ab from both sides of this equation. So if I do that, I'm going to subtract 2ab from this side and 2ab from this side, because what you do to one side, you do to the other side. And what's 2ab minus 2ab? It's 0. Okay, so that helps us out here because that means this goes away and this goes away. And look, we're finally done. A squared plus b squared equals c squared. That's it. Okay, we just showed that a squared plus b squared equals c squared for right triangles using the trapezoid, right? We took the trapezoid, we broke it up. First, we had this triangle. We built some stuff with it. We built this guy, right? Then from this guy, we went to this guy. And then from this guy, from this trapezoid, we went to this trapezoid, and then we broke it apart, and then we messed with the areas and stuff. All right, so we did the trapezoid area, and then we did the triangles area, and then this triangles area, and then we did all this algebra that you can go back and watch if it was a little confusing. We did all this algebra, and we end up with a squared plus b squared equals c squared. But why is that? Why is this so important? Because this a and this b and this c are the same a and b and c from the original triangles, the original shapes. So we get a squared plus b squared equals c squared, and that's the entire purpose of what we did in this video, or in these couple videos. Okay, so hopefully that made some sense. And there's one last thing that we need to realize, one last concept. Okay, so bear with me. I'm just gonna take this off. And there's one last concept that we need to realize. What we did in this entire video was this. We showed that the sum of the areas right? The sum of the areas, remember we added up all these areas, we added all these areas up. We showed that the sum of the areas of the three triangles equals the area of the equals the area of the trapezoid, right? Because we use trapezoid method. So what does it mean? Here's the most important part. What does it mean to use the trapezoid method to show that a squared plus b squared equals c squared? It means to show that the sum of the areas of the triangles of each three of these triangles show that if you add up all these areas with using like the letters and the algebra stuff, show that you'll get the area of the trapezoid. And when you do some other algebra stuff, you end up with a squared plus b squared equals c squared. All right, guys, so I know this is a long video, but hopefully it made sense. If you have any questions, feel free to ask. Okay, but that's going to be it for this video. Thanks for watching, and keep working hard. Thanks, guys.